Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome back to the world of phylogenetics. This is the fourth part of this topic um, and perhaps the second last part. Next part will most probably will be the last part and this topic will be covered inshallah. So in the previous lecture we talked about UPGMA method of constructing a phylogenetic tree, which is a distance based method, and today we will discuss another method which is also a distance based method, which is known as neighbor joining method. So let's start. In UPGMA method, molecular clock was taken into consideration. So the method assumed molecular clock, which means that the rate of change is constant in sister species. And because of this assumption, the branch lengths were equal. However, in neighbor joining method, there is no such consideration in this method, and therefore the taxa, they are not equidistant from the root. The rest of the algorithm is similar. We start with the distance matrix, and from the distance matrix we pair up the most closely related taxa, and after that we treat this pair as a new taxa and repeat the process again and again till all the nodes have been accounted for. Another difference between UPGMA method and neighbor joining method is that unlike UPGMA method where we just paired up most closely related taxa, neighbor joining method, before pairing up related taxa together, it corrects for unequal evolutionary rates between sequences using a convergence step. So we'll see what is a conversion step and how do we do these conversion steps later in the slides. Let's try to understand neighbor joining method using an example. Here we have four different sequences A, B, C, and D, and all sequences were compared to each other. And these numbers represent number of substitution between pair of sequences. Uh, these values were filled up in this matrix, also known as a distance matrix. And to start with, we'll make a star-shaped tree. Now a star-shaped tree has a central node also known as a hub, and all the taxa, they are connected with the hub. And our aim is to resolve this tree. So in neighbor joining method, there are a set of instructions that are followed, and each set of instructions are followed, and they are repeated again and again until the whole tree is resolved. In this example, I'll just uh, discuss with you. I'll just show you how to compute the values using different formulas for round 1 only. For round 2 and round 3, you will have to compute the values yourself. I'll just show you the values, final values in the matrix, and you'll have to compute the values to see if those values are correct or not. Okay, so the first step of this algorithm is to compute the r prime I values for each terminal node, and that can be computed using this formula. So now this formula seems a bit difficult. I'll just show you that what are different components of this formula. I and j are two taxa. Okay, so if you are computing the values, I mean I is, it can be taxa A, it can be taxa B, it can be C, or it can be D. So you'll have to calculate the distance between A to B, A to C, A to D, and then you will calculate the distance between B to A, B to C, B to D. Similarly, C to A, C to B, and C to D, and then D to A, D to B, and D to C. Okay, at this end here, it is the number of taxa. Okay, so here we have a number of taxa. We have four taxa A, B, C, and D. So n is 4 minus 2, which is equal to 2. So we'll divide it by 2. So let's compute the values r of I values. So first we'll compute r of A value. Okay, so to compute r of A values, we'll see what's the distance of A to every other taxa. So A to B is 17 plus A to C is 21 plus A to D is 27. Divided by 2 and you will get 32.5. R prime to B, we have B to A, which is 17, B to C is 12, B to D is 18, divided by 2 and then you'll get 23.5. Similarly, R prime C is C to A, which is 21, C to B is 12, plus C to D is 14, divided by 2, and when you compute the values you will see it's 23.5. Similarly, you will calculate the R of D value. So here you'll try to compute R of D value yourself. Pause this video here and see if you can compute the value of R of D. And once you have computed the values, here are the values. Okay, so now you have filled you have mentioned R of I values in your distance matrix. So now we have our distance matrix and we have computed R prime I values in the previous slide. Now in this step, we'll if you remember, in the beginning I told you that neighbor joining method, it does a conversion step to correct for unequal evolutionary rates between two species. So in this step we are going to update our distance matrix to adjust those corrections, and this can be done using this formula. Okay, so I'll try to use this formula to compute the distance matrix. So d prime ij, I is a, b. Okay, first we'll calculate for a and b is equal to distance of I to j. Distance of I to j is basically distance of a to b, which is 17, minus r prime I value. I here is a, r prime of a is 32.5, minus r prime j here is b, so r prime j value is 23.5. If you calculate this value, you will get minus 39. Similarly, now we will ij will be a and c. So d prime AC is equal to distance of A to C, which is 21, minus R prime A, which is 32.5, minus R prime C. R prime C value is 23.5, and here you will get minus 35. Distance of A to D will be calculated as the observed distance between A to D, which is 27, minus R prime A, which is 32.5, minus R prime D, which is 29.5. If you calculate these numbers, you will get minus 35. Similarly, d prime of BC will be computed, d prime of BD will be computed, and d prime of CD will be computed. So pause this video here and compute these values yourself and see if you can compute the values correctly or not. So once you have computed these values, an updated distance matrix d prime can be made with values that are now corrected for different evolutionary rates between different species. So here is an updated matrix, and if you see in this matrix, the least values we have is -39, which is between A to B or C to D. So any of these two taxa can be joined together using a node, and in this example we'll consider joining C to D first. Okay, so when you join C to D, you'll get, a partial tree. Now you have C and D connected to a node which is represented by as U in this example. Now the third step of neighbor joining method is to calculate the branch lengths. In the previous step number 2, we joined together C and D via a node U, but the branch lengths were equal. Now we'll have to calculate the actual branch lengths, and those can be calculated using the distance matrix and r prime r values. Okay, and the distance between, so we had C, we had D joined together with node U. Okay, so we'll have to calculate this value and this value. That can be done using these two formulas. So let's use this formula. V of I mean the branch length of I here is C. Okay, this is I and this is J. So I here is C. So to calculate the branch length of C to U, we'll use this formula, this one. Okay, so V of I is equal to 0.5 times distance of I to J. The distance of I to J means distance of C to D here is 14 plus 0.5 times r prime I value, I r prime a C is 23.5 minus r prime j, j here is D, so r prime D is 29.5, which will be 4. Similarly, to compute the distance between D to U, we'll use this formula. Okay, V of J will be 0.5 times distance of IJ, distance of C to D is 14 plus 0.5 times R prime J. Okay, so R of J, J here is D, so R of J is 29.5 minus R prime I, which is 23.5, which will turn out to be 10. Here you see that in both these formulas the difference lies here. So first we have R of I and then R of J, here we have R of J and then R of I. Okay, so now we have computed the branch lengths, which is 4 and 10. We can reconstruct those two C and D taxa together, and we'll get uh, C and D joined together with U, which different with different branch lengths. C to U is 4 and D to U is 10. So now we have calculated the branch length. Now we'll move to the next step. So now we have joined together C and D, and we have also calculated the branch lengths. The next step is to repeat those steps again, but before that repetition we'll have to calculate the updated distance matrix, because if you remember in UPGMA method, when we join together two taxas, we considered that as a single taxa in the subsequent steps. So here also, since we have combined or joined together C and D via node U, so now we can see here that the new distance matrix will have C and D together. Okay, so we have to compute these values and also R prime I values here. So to compute A of B, we don't have to compute the value, we'll just have to look at the previous distance matrix to see what's the distance between A to B. So the observed distance of A to B is 17, right, 17, and then we'll have to calculate distance of A to CD and then B to CD, and to do that we'll use the formula that is shown here. But before, just concentrate here that this is the D prime of I, J and K. I, J in this case is C and D, because C and D are together now, and K can be any other taxa. In this case it is A or B. So in this case you will compute the values of CD to A and also CD to B using this formula. Okay, so let's try to see how can we compute the values for uh, our next distance matrix. So D prime Ij and K, Ij is CD and K is A in this case. This can be computed by adding the distance between I to K, which is C to A. C to A is 21, plus distance between J to K, J is D, K is A. So distance between D to A is 27, plus, sorry, minus uh, distance between I to J, means distance between C to D. C to D is 14 divided by 2, and this will be, when you compute this value you will get 17. Okay, so write 17 here. Next step, D prime CD to B. This can be computed by adding distance between C to B. C to B is 12, plus distance between D to B. D to B is 18, minus distance between C to D, which is 14 divided by 2, and you will get 8 here. So you'll write 8. So we have filled the distance matrix. Now you'll have to calculate the R prime I values. R prime I values can be computed using the formula given in the previous slides. You can refer to the slide where we discussed round number 1, step number 1. Using that formula, you should compute the values yourself. And once you have computed the R prime I values, your distance matrix will look like this. Okay, let me rub this for you. So now you have your new distance matrix, and you have computed the R prime I values. The next step is the same. You'll do the corrective step. Okay, you'll do the corrections in your distance matrix and update your distance matrix, and then you'll join together two new taxas and compute their branch length. Okay, so let's move on to next slide. So now step 2 is to uh, cal compute the values for D prime matrix. You have the distance matrix here and you have the R prime I values. Using these values you'll have to compute the corrected distance matrix, just like we did in round 1, step number 2. Okay, so go back to that slide, see the formula and try to compute the values yourself. I'll just show you the values here. When you compute the D prime matrix, your D prime matrix will look like this. So distance between A to B is -2, distance between A to CD is -42, and distance between B to CD is also -42. These are the corrected distance now. So here you can see the least value is -42, which is present in all three cells, and again here you can join any of the two taxa together. You can join together A and B, you can join A with CD, and you can also join B with CD. Okay, for this example, just to make it simple, we'll join together A and B. Okay, and when you'll join together A and B like this, we have A and then we have B joined together with a node V. Okay. So now these two taxas, they have been joined uh, via node V, and then you'll have to calculate the branch length. A branch length can be calculated using the formula. Also, you'll have to refer to the previous slides for the formula. And once you compute the branch length of A to V will be 13 and B to V will be 4. So now you have calculated the branch length also, and you have computed most of your tree. Okay, so let's move on to next step. So in round 3 again you'll have to update the distance matrix. Previously C and D were put together in the distance matrix. Now A and B are also been kept together in the distance matrix, and you don't have to calculate R of I values here. You'll just have to compute the values for A, B to C, D, which turn out to be 4. Okay, so the distance between A, B to C, D is 4. You can join the two folks there that in previous slides we joined together C and D, and then we joined together A and B, and now you can join A, B to C, D with a branch that has a length of 4. Okay, so now you have your unrooted tree, the whole tree is resolved, and we'll stop here. Okay, and one interesting thing is that if you look at this tree and see the branch lengths, so if you add like if you add the distance between A to C, so 13 plus 4 plus 4, if you add these three values, you will get A to C is 21. Similarly, if you see 13 plus 4, distance between A to B, distance between A to B is 17, so 13 plus 4 is 17. So if you go in any direction and see what's the distance between two nodes, they will correspond to the observed distance in your distance matrix. Okay, so this is how neighbor joining method works. I hope you have understood uh, this method and how to use the formulas, and I'll encourage you guys to do it yourself at least once, and before that you should do the round 2 and round 3 calculations yourself to see if these values are correct or not. Okay, so until next topic, Allah Hafiz, and we'll meet in the question answer sessions.